Hi everyone, this is Illia from Near. I'm going to talk about economics in our new episode of Launch Series. So let's start kind of to compare how the economics in sharded blockchains differs from economics in kind of regular blockchain with one chain. So right now, if you think of it, when we produce a block, right, there's a limited capacity how much you can have of transactions. And as kind of blocks end up filled more, naturally you're starting to compete for resources. Naturally you're starting to compete for the size, for the space in the block, for processing, for space, etc. And to prevent that, we have pretty much a market price for the transaction fee in the system, and it goes up as the blocks get filled. Now, in kind of sharded blockchain, one of the main points is that we scale and don't have a problem of limited block sizes. So instead, we have multiple chains kind of going in parallel that pretty much can take over some of this capacity and balance out the size. Now, there's different sharding designs, and actually, depending on the sharding design, the economics of this is very different. Today we'll talk about night chain design, and specifically a few of the things we're doing to make sure that economics is both straightforward for developers and balances out. So, kind of one of the important things is that if you put, if developers can put their applications into a specific shard, right? So you have shard 1, shard 2. They can decide, oh, I want to be in shard 2. Let's say it's less used. I can see there's, the prices will be lower. If you allow them to do that, what this means is now some other people may want to kind of join them there. And as we saw in Ethereum, one of the kind of main values is cross-application interaction, composability. So if I want to work with this other application, let's just say Maker decides to live in shard 2. My application wants to interact with Maker. I want to use DAI in my application. I will want to live in the same shard. And obviously, let's say this was Compound. Somebody else wants to kind of plug in there as well. So as this starts to happen, this shard will actually start fill up as well. And at some point, the prices here will start going up as well. This creates a lot of kind of pervasive incentives on the application developers as well as in general on the whole system. Now, the other kind of consideration we should keep in mind is that the cross-chain communication is actually, depending on design, may take some time. So one of the things we're doing in Nightshade is making sure that the kind of receipts get rerouted every block. And you can check out the previous episode to learn how exactly this is done. To kind of compare this in some of the other approaches, if you are using, for example, a beacon chain that might be producing blocks less frequently or actually just has this cross-linking happening less frequently, that means that the price of communication is actually might be more expensive. And as soon as you have more expensive price of communication, this means that if my app lives on this chain, the price of even using DAI starts to become higher. Because it's not just that I need to create a transaction here, I also need to execute something there as well, pay for cross-shard communication, and wait for a period of time within which somebody can front-run me and do all kinds of interesting things. So again, in Nightshade, we're trying to prevent all this, and we're trying to make sure that developer, in a way, doesn't need to think of sharding, and instead just deploys application and uses them in a straightforward way. So the idea is that as a developer, you just deploy an application, and it gets assigned to one of the shards depending on the current layout of the network. So to do that, one of the things we're doing is called dynamic sharding. This is the idea that if you have all your contracts, let me draw this differently. If you have all your contracts kind of laid out on some space, for example, this is just a hash of account ID, and each contract has, some amount of transactions that have happened during the period of time, or specifically more like gas spent, on this contract. You want to split it into shards, trying to balance out that each shard has about the same amount of gas spent per epoch or per some period of blocks. Because this is now done dynamically, developers, even if they try to live together with some other contract, even if they grind account IDs or whatever, they may end up still being in a different shard, right? So you're kind of removing this incentive for them to live in the same shard and trying to be as close as possible. Instead, you actually allowing this idea of like rebalancing and pretty much trying to smooth out the economics of the system instead. Now, the other thing this, like in Nightshade we do, right, is we make sure that transaction receipts happen within the same block. This pretty much provides us with the idea that even if the two contracts live in the same shard right now, because of, they end up in the same shard, we still actually create cross-shard receipts for the next block to execute here. Which means that as a developer, you really don't have any kind of difference if your app lives in one shard or in different shards or the same shard with what you want to operate with. So it always happens asynchronously. This also has a huge benefit of actually being able to execute this processing in parallel, because you now don't have any synchronization within the block. And there's like lots of benefits around that. Now, what this means is that when the blocks are produced, right, when you're only producing a block, in proof of stake, what happens is we don't actually execute it, because you only need to assign the transactions that will be in a block and publish it and start accepting approvals. Which means the kind of cost for a block producer at the moment is actually not proportional to the transaction weight or transaction gas, but instead just kind of proportional to the size. And this kind of leads to a next interesting thing, is that because of the way we want to make sure that the security of the system is as a whole, by pretty much having what we call hidden validators. So this is validators that are validating kind of each validator validates subset of shards, but all together they validate the whole blockchain and provide security for the whole blockchain. And you cannot like individually assign to them, oh, this guy validated this subset of shards and this amount of gas was executed there, etc. So now what this means is you actually reward the whole system, right? Instead of splitting, oh, this block producer produced this block and did this much work, instead you're saying, well, the whole system did this much work. This validators provide security for all of this work, and by work I mean actually executing transactions and processing state. So now we're kind of going away from this idea that each block producer competing for transactions. Instead, the kind of cost of executing is being split between all of the participants in the system evenly. So that's, or like proportionate to how much actual participations they've done during this period. So that's kind of one of the important things, is that we're trying to remove a lot of incentives that in the current blockchains are around like competing, instead to kind of collaborating. And here, like this counterweights that like if somebody tries to, pretty much compete in some ways, they will be kind of punished by everybody else economically.
How is it happening? The punishment?
Well, the punishment, I mean, by like what is the ways to compete? This is, so in proof of stake, right, you actually have assignment for each slot who needs to do which work, right? So the only way to compete is actually to skip. So like, let's say somebody builds a blockchain and I want to compete, right, by getting all the transactions to myself. So the only way for me to compete is actually to skip all those guys and take all the transactions from them to my block. That's really the way to compete. Now, because the way the reward is done, it's actually smeared among all the validators. So in reality, that's not really helping you in any way. So the only way is like if you are the only person in your chain and you collect all the transactions, that's the only way to do it. But then obviously this chain has way more validators and will be preferred. So you'll get nothing.
But inside the shard, we don't have the fork choice rule, right? It's only like we don't have fork choice rule inside the shard anyway. So how?
Yeah, I'm talking about the whole system. So because from our perspective, right, transaction routing happens kind of within one block, and we kind of dynamically reshard. The way I model this is that it's one chain. Like because really within shards, like we're trying to remove all the kind of sharding details, right? Then as a validator as well as a developer, you don't need to think of sharding.
So the people who could have competed are block producers, but they won't because we smear the rewards.
Exactly, yeah. Yeah, and like validators cannot compete for anything anyway. They just they're literally receiving block and executing it and just making sure that all the Merkle proofs are correct. And if they're not correct, they're slashing, and that's a separate topic. But that's the idea, is that you actually, pretty much remove the incentive for block producers to do a lot of things that in proof of work, for example, this is actually a very valid idea, and then you start accumulating more weight on top of this by trying to skip. Right, so this is one part. There's a lot more detail here. There's a paper being published with all the details around this. Now, so the interesting part here is like, how do we get block producers and heal validators elected, right? So yeah, to just finish on the rewards part, right? So now, given we have kind of dynamic number, and one of the ideas here is that actually you can grow number of shards. So let's say the amount of gas that has been used within last block is actually went up over previous period of time. What you can do, you can actually allocate new shards and pretty much resplit it, dynamically resplit it. Now what this means is that you're actually never hitting the cap of the kind of capacity, which means like if you run just the regular auctions, like your price will never go up. Except within, let's just say like there's an epochs, right, half a day. So within epoch, you can actually have like a gross happening, and then you reshard, and it kind of like will reset again, right? So that's the idea. Like if the total gross happens like this, but within each shard, it kind of starts from the zero every time we reshard. So like one of the main concerns with, for example, Ethereum is that given the auction, it's very choppy, right? Like this block, there is a lot of interest, and the price went up, and then next block there's nothing happening, and it ended up being gas being cheaper. So actually, this idea from Vitalik is to pretty much have a formula which is predictably changes gas over time, and it depends on if the blocks are less than half empty, then the price goes down, and if the blocks are kind of more than half full, the price goes up. So kind of taking this idea, right, you can actually say that gas price is a how much gas was used divided by gas limit minus half multiplied by some alpha. So alpha is like how much you want to change each block. So then within an epoch, right, you have this idea that like price will slowly kind of increase, but in a predictable way. So you can actually like look at the block, and even if you assume that the next block will be half full, which also does not apply to you, but like let's say your transaction gets included only in a few blocks, you can assume what the gas price will be and have a predictable way.
Do I have gas price within a shard or within an entire blockchain?
So that's a good question. So if you have gas price within each shard, this actually creates a huge problem for developers, because let's say my contract wants to call contract to another shard, this will call some other thing, will come back, right? Actually paying for this process will become extremely hard because you don't actually know by the time you get there what the price is going to be. So instead, we suggest to, in a way, a little bit misprice the gas, because obviously different shards may have different gas price because of the usage at the moment, but instead make it simpler where as the transaction comes in, it buys, the price is the same across all shards, it buys this gas for the full processing across all shards and then gets routed. And then you just get a refund at the end if there's something left. So obviously this is not like there can be a shard that's fully used right now, but this is only kind of mispricing within this one epoch period of time. So as a tree shards, you kind of rebalance everything again and can process it properly.
Our current implementation of runtime fees heavily relies on this model.
Yes.
So if we decide to deviate from it, we need to.
Yeah, I mean, I don't think as far as we know, there is no other model has been published that actually clearly explains how would you charge in multi-chain environment, and it's unclear that any as a developer you will be able to properly price it, because properly model this pricing, unless prices are kind of don't exist in the first place. That's the only other option is no gas prices whatsoever. So the only way in a really multi-chain environment is somewhere you prepay and then you kind of get to use whatever the multiple chains that you have. I mean, there's a lot more details how all this kind of ties together. There's also a lot of interesting possibles to attack right now. So the shard producers can try to withhold transactions to pretty much bump up the price by waiting out until they collect maybe 100 or 1,000 blocks of worth of transactions and then rolling them out to push the price up. Now, one of the things that we've done is each transaction has TTL, time to life. So, which means that even if validators start to kind of withhold them, they actually will just expire over time. One of the other thing is in this system, you may end up in a state where the gas price actually just keeps going down, right, until it hits whatever your numeric numeric space is. So here we still add a min fee or min price, and this is just both to prevent numeric errors, but also at the end validators actually have some costs associated to block production, even though they don't actually execute it at a time. But there's a block production. So if the price goes below their block production cost, they will kind of stop accepting transactions, period, because they can just produce empty blocks and receive rewards. And this is pretty much targeted to prevent that. Obviously, this is also mispricing it in some ways, but at this point, this is kind of a best way to model this.
Why would it keep going down at all?
Well, let's just say we have an empty blockchain with less than half full blockchain. So we're always less than half full. The price is going down because there's no competition.
But then dynamic sharding should kick in and we start shrinking the shards until the actual...
Yeah. So we will shrink the shards, but what you want to model here is actually hit half full across the blockchain, because then you have space to fill in. So yeah, ideally it will balance on a half full all the time.
It should oscillate, right? Around
Yeah. So that's the idea. It should oscillate around half full all the time.
If it balances towards everything approximately half, then some shards are a little less than half constantly, while some others are always a little more than half.
And that's why this is actually smeared across all shards. So gas used, gas limit is aggregation of gas used across all shards. But exactly, I mean, this is more like a stopper in case, let's just say, nobody uses blockchain for a period of time. as we launch, like hopefully we'll have a lot of usage. But it makes sense to have some, mechanics to prevent it. So just to finish up, one more interesting thing is now we have this idea that like the network grows with usage, and we have this idea that validators or block producers are not competing anymore for transactions, right? So this is very different from proof of work systems where people are actually competing to include transactions in their block, right? And there's a lot of kind of possible issues with this, especially in Bitcoin, as kind of Coinbase or inflation starts to go down. People now can prefer to, instead of building on the longest chain, actually steal transactions from the longest chain, or split transactions into ones that they include and ones that they will give to a next block producer, right? So there's a lot of interesting research on that, like on Bitcoin issues with this. Now we're kind of sidestepping all that, and what this allows to do is to actually have a inflation that incentivizes directly this, right? So it incentivizes, so given reward and giving, let's say, gas used, we're actually incentivizing people to produce blocks. Let's just say at the incentive, like target incentive is inflation at 5%, or like 5% of Coinbase per year. As gas getting used more, right? The idea is that your inflation actually gets lower. And then as we hit 5% from there, it actually can keep going. Now, obviously, this is like actually a lot of gas use. So the idea is that we target like a really large network with a lot of usage. But the very interesting point here is that like as we reduce, like the proportion of the kind of inflation is very much dependent on how much usage the network gets. So the more network used, the better store of values this becomes, and it pretty much kind of contracts a lot of this negative elements of the current proof of work systems.
So wait, if we have a lot of usage, we're not just going to not have any inflation?
Yeah. So at this breakpoint, which is I don't remember exact number, but it is a fair bit of transactions per second. Well, it's like a gas per second, really. Actually, yeah, pretty much inflation disappears, and this becomes fully just sponsored by transactions. But if people stop transacting, then it kicks in again. So it's the idea that we're actually balancing these two things in a very direct way, instead of saying that, hey, in 2020, whatever, there will be no inflation, figure it out. And we think this is actually a very interesting model to kind of target some of the properties that people really want from blockchains. This is it for episode number 2, and we will tune in more to learn more about other components.